This is Core 7, the strangest object in the Petrie Museum, and most visitors walk straight past it. It sits in a glass case in University College London, a small pinkish cylinder of granite about 3.5 inches long. It looks like a piece of broken stone. It is a piece of broken stone, but on its surface, running around the cylinder from top to bottom in a single unbroken line, is a spiral groove. The groove looks like the thread of a screw, a continuous, even, machine-cut helix wound into one of the hardest stones the planet produces. The object was excavated from the rubble around the Great Pyramid of Giza by the British archaeologist William Flinders Petrie in 1881. And for nearly 150 years, no one has been able to explain how the ancient Egyptians made it. That's a strong statement. It deserves to be backed up. So before we get to the theories about lost technology, let's look carefully at what the object actually is. A drill core is the piece of stone that comes out of the middle of a hole. When you drill a hole with a hollow tube, the tube cuts an annular ring into the stone, and as it descends, a solid cylinder of stone remains in the center, attached at the bottom. When the drilling is finished, that center cylinder gets snapped off and pulled out. What you have left is the negative of the hole, the drill core. Modern engineers do this every day with diamond-tipped tubular drills. The cores produced by those drills are clean, smooth, and covered in concentric rings, the marks left by the abrasive as the tube rotated. Core 7 has those rings too, but it also has something else. Cut into the rings, in a section near one end, is a spiral. A single continuous groove, traceable through 5 complete revolutions around the cylinder, descending at a measurable pitch. The pitch is what makes the object impossible. Petrie, who was the founder of modern Egyptian archaeology and a careful measurer of everything he ever touched, measured the spiral. He published his measurements in 1883 in The Pyramids and Temples of Giza. The groove, he reported, descended approximately 1/10 of an inch per revolution of the drill. That is the feed rate. It is the rate at which the tool advanced into the stone with each turn. That figure, 1/10 of an inch per revolution, is the number that has refused to go away. A modern, diamond-tipped industrial drill, cutting into the same kind of granite, advances at approximately 2 ten-thousandths of an inch per revolution. The ancient feed rate, taken at face value, is roughly 500 times greater. 500. Not 5% faster, not twice as fast. 500 times the depth per rotation of a diamond drill spinning at 900 RPM. Modern researchers have generally pointed out that the comparison is misleading, because the ancient drill almost certainly rotated much more slowly than 900 RPM, which would reduce the actual time per hole. The total speed of drilling in holes per hour was probably nowhere near 500 times faster than ours. But the feed rate itself, the byte per turn, is what Petrie measured. And that number does not have a comfortable explanation. Because to cut a spiral into granite, the tool has to advance into the stone with force, smoothly and continuously, while rotating. That requires 3 things simultaneously: a cutting medium hard enough to abrade quartz crystals, a rotational mechanism stable enough to keep the spiral consistent, and a downward pressure great enough to push the medium into the stone fast enough to leave a groove 1/10 of an inch deep per rotation. The Orthodox account of Egyptian stoneworking technology, copper tubes filled with quartz sand and rotated by a bow drill, gives you the first thing. It doesn't obviously give you the other two. Granite is hard. Think Aswan granite, the kind Core 7 was cut from, registers around 6 to 7 on the Mohs scale. Copper, the metal the ancient Egyptians had in abundance, sits around 3. You can't cut a 6 with a 3. What you can do, and what the Orthodox account proposes, is use the copper as a soft carrier for a harder abrasive. Pour quartz sand into the groove, press the copper tube down, rotate it, and the sand particles between the metal and the stone do the cutting. The copper tube wears down, the sand wears down, the granite wears down too, very slowly. In the 1990s, an experimental archaeologist named Denise Stocks set out to test this. He built copper tubes, mixed quartz sand, and drilled into granite using bow drill techniques. He published his results in a book called Experiments in Egyptian Archaeology. His conclusion was that the method works. You can cut granite with copper and sand, you can produce drill cores, you can produce concentric striations on those cores. The Orthodox theory, in his careful and exhaustive testing, was largely vindicated. But Stocks himself was honest about the limits of what he had demonstrated. Cutting was slow. The copper wore down rapidly, at a rate where every 100 units of stone removed cost roughly 1 unit of copper barrel. The striations he produced were horizontal, ring-shaped. They were not, in the cores he made, the helical, screw-thread groove that Petrie had measured on Core 7. Stocks noted that horizontal striations are what his method produced. The spiral was something else. This is the detail that splits the debate. and it's the detail the alternative history side has built its entire case around. The case is most associated with an engineer named Christopher Dunn, who spent decades working in precision manufacturing in the United States. Dunn examined Core 7 in person at the Petrie Museum. He published his analysis first in Analog magazine in 1984, and later expanded it into a book called The Giza Power Plant. His proposal was that the spiral feed rate cannot be reproduced by manual drilling with abrasive sand. The combination of consistent helical pitch, depth, and concentric striations, in his reading, requires a tool that's being fed mechanically into the stone by a fixed pressure or screw mechanism at a rate determined by the machine rather than by the muscle. He went further. He suggested that the rate of cutting, particularly the apparent speed at which the tool advanced into hard granite, points to a method called ultrasonic machining. In ultrasonic machining, a tool vibrates at very high frequency, hammering abrasive particles into the workpiece thousands of times per second. The technique is used in modern industry today. It's excellent at cutting hard, brittle materials, and it doesn't require a tool harder than the stone because the cutting is done by impact, not friction. Dunn's proposal is, by his own admission, speculative. There's no physical evidence in the archaeological record of an ultrasonic drilling apparatus from ancient Egypt. There are no surviving tools, no parts, no diagrams, no inscriptions describing the technique. But there is, in his framing, the residue of the cut itself, the spiral, the depth, the consistency. He argues you don't need to find the machine. You need to find what the machine left behind. And what it left behind, in Petrie's Core 7, is a signature that no one has reproduced with copper and sand. The Orthodox response, from researchers like Stocks, and from the Penn Museum team that conducted independent drilling experiments published in Expedition magazine, is that there are simpler explanations available. The spiral on Core 7 may be an outlier. Most of the other drill cores Petrie found, and the cores produced in modern replication experiments, show concentric circular striations, not helical ones. The spiral on Core 7 may be the result of an irregularity in the drilling process. A core that broke partway through and was re-drilled at a slightly different angle. A momentary slip of the drill. Scratch made by a fixed point of harder material that got embedded in the copper for a single descent. The single anomalous spiral on one particular core may not represent the typical method. It may represent a single odd event that happened during the production of one piece of stone. This is a serious objection, and researchers studying the same object have pointed out an even more uncomfortable detail. On Core 7, there appear to be two machined surfaces visible, not one. There's the smooth, cylindrical surface that resembles all the other drill cores Petrie found, and there's the helical groove cut into that smooth surface. The two surfaces appear to be sequential. The smooth surface came first. The spiral was cut into it afterward, by a different process or a different tool, in a way that's genuinely difficult to explain. The mystery, when you look closely, is not the entire core. It's the spiral, sitting on top of a more conventional drilling signature. So what does the evidence actually say? Honestly, plainly, without leaning toward either side, the evidence says that the ancient Egyptians cut hard stone, including granite, with a precision and consistency that has been verified across thousands of surviving objects. The evidence says that copper tubes with quartz sand abrasive, operated by hand over long periods, can produce drilled holes and recovered cores in granite, including some of the visible striations on those cores. The evidence says that the specific helical groove on Petrie's Core 7, with its measured feed rate of approximately 1/10 of an inch per revolution, has not been reproduced in any documented experimental replication of the orthodox copper and sand method. The evidence says that the spiral appears on one particular core, possibly cut into an already machined surface, and that most other cores from the same period do not show this feature. And the evidence says that no physical apparatus capable of cutting that spiral, whether ultrasonic, mechanical, or otherwise, has ever been excavated. You can hold all of that in your hand at once. You don't have to pick a side. The orthodox view is that the spiral is an anomaly within an otherwise well-understood technology. The alternative view is that the spiral is a window into a technology we no longer possess. Both positions are coherent. Both rest on the same physical object, sitting in the same glass case, on the same shelf in the Petrie Museum. What the spiral cannot do is disappear. This is what makes Core 7 different from most arguments about ancient lost technology. It's not a story passed down. It's not an inscription that might be misinterpreted. It's not a myth. It's a piece of granite, slightly larger than a paperweight, with a measurable geometric feature carved into its surface. You can measure it. The measurements have been published. The measurements have not been satisfactorily explained by any method currently known to have been available to the people who made it. That's not a wild claim. It's a constrained, technical, narrow disagreement at the intersection of archaeology and mechanical engineering. The disagreement has consequences beyond the core itself. Across Egypt, in the granite sarcophagus of the King's Chamber of the Great Pyramid, in the basalt paving stones of the mortuary temples, in the diorite statues of the Old Kingdom pharaohs, the same level of stoneworking precision appears again and again. Holes drilled through stones harder than copper, claw marks that run straight for meters without wandering, surfaces flat to within a fraction of a millimeter. Modern stonemasons examining these objects often say what the visitor to the Petrie Museum says, looking at Core 7. They say it looks like work done by machines. That impression may be wrong. It may be the result of generations of skilled hands and an underestimated abrasive technology. The Stokes experiments suggest as much, at least for the bulk of the production. But the spiral on Core 7 sits inside that conversation as a small, hard, unresolved point. The Orthodox account has not yet absorbed it cleanly. And the question it raises is the same question that haunts the rest of the Egyptian record. Not did they have lasers, not did they have power tools, something more careful, more troubling, harder to dismiss. Is it possible that the people who built the pyramids knew something about cutting stone that we have not yet rediscovered? Not a wild magical technology, just a method, a trick, way of fixing an abrasive that doesn't slip, way of feeding a drill bit smoothly into rock with mechanical pressure that doesn't vary. A clever solution, lost to the centuries, that left its signature on a single piece of granite the size of a child's hand. The signature is still there. You can see it in the glass case. You can trace it with a piece of thread. 5 turns of an unbroken spiral, cut into rock that should have resisted the cut. The ancient Egyptians, by every other measure, were ordinary humans, brilliant builders, brilliant artists, brilliant administrators. Ordinary in the sense that their bodies and brains were the same as ours, and they did not have access to physics we don't have access to. If they cut Core 7 with copper and sand, then they used those materials in a way that has not yet been figured out. If they cut it with something else, then the something else has not yet been found. Either answer is unsettling. Both answers point to the same, uncomfortable place. Somewhere in the long span of human history, in the lifetime of the men and women who quarried the Aswan granite and floated it down the Nile and lifted it onto the Giza plateau, a technique existed for cutting hard stone that the modern world has not yet reconstructed. The spiral is still there, the case is still open, and one small cylinder of pink granite, sitting quietly in a museum in London, is still asking a question that nobody, in 143 years, has managed to answer.